Hello everyone, let's talk about time series analysis. There is a best model called ARIMA, ARIMA, ARIMA model, and this is used for forecasting. ARIMA model, let's talk about it. What is ARIMA? ARIMA is nothing but it's mostly widely used time series model for forecasting. It is not based on any theory, it is based on statistics and mathematics. We have, if we talk about ARIMA, right? AR means auto-regressive, I means integrated, MA means moving average, right? So this ARIMA model can be performed in non-seasonal or seasonal data, or maybe seasonal plus non-seasonal. Two data we can perform ARIMA model. So let's talk about ARIMA, right? What is the first steps in ARIMA? ARIMA, first of all, we have to check I process. I process in the sense, in the integrated, AR means auto-regressive, I means integrated, MA means moving average, right? We first need to check I process, that is integrated. So data in integrated I process, there has to be there is a things that need to be considered. So first in I process we have to see that data must be stationary. Stationary data means the data which are in a graphical line, right? It goes up down with zigzag format, right? But it is, if you put some scale in that data, this kind of data, if you put that scale, so it should fall inside the scale, and so that data has to be more and more and going up down, like it is looks like some kind of train, but not exactly train, but it is kind of these things, kind of data are scattered in one line, right? So data must be first data must be stationary. We always start with I process, as I told in ARIMA. Check if the time series data is stationary or not using unit root test. So you have to test the data stationary, right? If you perform unit root test is there, means there is no stationary. Unit root test, some values are there, means it is not stationary. If unit root test is not there, means data is stationary. So after that, what we use, ADF test here. So we also consider ADF test, that is statistical package used in our program. So we perform ADF test. Then if data is stationary, then it is labeled as d equals to 0. D means difference, right? If data is, if you test through root test, sorry, that root test, right, unit root test, and you found that data is stationary, means data label d equals to 0. If no is stationary, there is difference is needed. If data is not stationary, in that case what you do, then first difference is done and it is labeled as d equals to 1. So you have to do a difference, then you have to make it as a d equals to 1 if data is not stationary. We can do up to d equals to 2. We cannot exceed the number of 2, right? If you exceed that, means this model you have to stop it there. I process, you have to stop it there. So in ARIMA, need to start from I integrative process, as already told you. One difference, so we have talked, right, d equals to 0. If there is a difference, means what is that? If you consider one difference, means you are from original value you are subtracting one value, right? Two difference means from original value you are subtracting two value, right? So that things comes in this model. So there is another thing you need to consider in this condition, I process condition, stationary data property P and use, right? P1 constant mean, P2 constant variables, P3 constant autocorrelation. So those things need to be considered. P4 no trends or seasonality, you have to look. UI makes data predictable. U2 simplifies analysis. Those are the things you need to look at there. If we can't make stationary, make weekly stationary series. So you can, in a time series ARIMA model, right, If 1 year monthly you cannot find and data is stationary, means you can take 1 week data and make it stationary and perform the analysis, like a series, suppose yt is said to be a weekly stationary if it is satisfy the following properties. So in weekly condition, I told already discussed, right? If monthly is not available, yearly is not available, is not possible to make data stationary. So in that case, what you do is you take weekly data and make stationary and perform that, right? Weekly stationary series you can do. I mean to say, in order to make weekly stationary series, you have to check out some uh, points. The mean, suppose EYT is the same for all t, the variance of YT is the same for all t, the covariance and correlations between YT and YT means time minus n is same for all the each lag n equals to 1 2 3 means there has to be some condition has to pass in order to perform weekly stationary, in order to make data weekly stationary. Okay, so there has another thing you need to consider in weekly stationary. The last property of a weekly stationary series, the theoretical value of autocorrelation of particular lag is the same across the whole series. ACF plot you can use to see those stationary things, right? And intersecting property of a stationary series is that theoretically it has the same structure forward as it does backward, right? Those things you need to consider. And there is another thing, you have a lot of, now if we completed I integrated process, right, we have to move on second process, that is called YAMA, right? Sorry, AR means AR process we need to consider. AR means auto correlation, right? So in that process, what we do is data must not be auto correlated. Do you understand? Data must not be auto correlated. Suppose there is a data called 1960, 1961, 1962, 1963, 1964, 1965, right? If you consider 1962, 1961, that the data should not have a correlated to each other. 1961 likewise 62, there has this data should not be correlated. For a good forecasting, data must not be correlated as earlier discussed. For this we start AR1, you know, we do AR1, start with AR equals to P equals to 0, then 1 and 2. YT, there is a formula, mu is there, right? Series mean, that is called series mean, plus alpha yt minus 1 for AR1 model, that is a formula. Yt equals to mu, that is called series mean, plus alpha 1 y t minus 1 for AR1 model, right? So that we can consider need to fit and test. So we have to fit and test. So here what happened, we have to perform line test, right? In line test we have to perform already discussed, right? Time series I part we have to perform here, independence something, right? So for that what we do is our data is 12-month lag is Darwin Watson test not worked, right? Our data is 12 months, that's why Darwin Watson test is not worked. That's why we have to perform IACF plot we need to check, and we have to perform line, there is I test we have to done here. Our data is 12 months lag. So what we do, how we perform independent test. In independent test, check if the time series data has series correlations or not. We need to check that time series data series has a correlation or not. For that we can use PACF plot box Fisher test. If the data is not autocorrelated with its lag, then it is labeled as P equals to 0. Same thing repeated, right? Their data is not autocorrelated means P equals to 0 we can consider. No correlation, adjustment is needed, right? If data is autocorrelated with its lag, then first adjustment is done and it is labeled as P equals to 1. If there is correlated, earlier discussed, we can go up to P equals to 2 manually, right? First not worked, we can put 1, and second not worked, we can put 2, but we cannot go above the 2, right? We are bound up to 2 only. So Simulated data AR1 model, what there is one example called sub-simulated data AR1 model needed. What it's needed? No constant trends upward or downward, no constant trends needed, no seasonality, no obvious outlier, variance is constant. So next step, move to correlation variable and time, right? Correlation of into time xt with xt minus 1 0.5 for positive correlation, right? There is one example, you just consider it. Although it's only a moderating strong relationship, there is a positive linear association, so on. AR's one model might be a useful model, so we can have some example and consider that. There is a last process in ARIMA, that is MA process. We can call it as a moving average, right? In this process, what one error and below errors should not have correlation. This moving average process, what it tells, one error and below errors should not have a correlation. So let's go stepwise. Data and forecasting is related with current and previous error, right? Current error and previous error. So what we do, fit line regression with original data error term, we can call it as a noise also. White noise, we can say white noise also. Modal error plus error one step forward lag, white noise we can call it, right? Start with MA equals to Q equals to 0, then 1 and 2. Then there is a formula is there for this MA process, YT equals to ET plus what? ET plus, there is a theta 1 ET minus 1 for MA1. Likewise, we can do ET plus theta 1 ET minus 1 for MA1, right? That already told you. Where ET is white noise, suppose ET is white noise, errors are uncorrelated with each other, mean of 0 and constant variables. So here the condition is mean of 0 and constant variables. So we can perform like this. After that, what we do, use ACF and PACF plot to determine MA process, right? What are the plots, what are the visual graphics, so that we can see whether this data has a MA or not, MA processing. So we use ACF and PACF plots to determine MA process, right? If the data residuals and lagged residuals are not correlated with zero mean and constant variables, in that case we already discussed Q equals to 0, no adjustment is needed. If the data residual and lagged residuals are correlated or have non-zero mean or non-constant variables, right? In this case, what we do, we adjust once and label as a Q1. We can add up to manually, as already discussed. We can 2, right? Above 2 we cannot go it. So that is finalized. So now let's come to a real one. So ARIMA, P means P comma Q comma P comma D comma Q, right? In real work, how it is done. So P means auto regression, D means difference, Q means MA, right? What I said MA above? MA process, I told you, right? What is MA process? MA means moving average, right? So ARIMA, there is small cost P comma D comma Q, right? P stands for auto regression. We have to do D difference, Q equals to MA, moving average. So the idea is the find the best ARIMA model using combine of P comma D comma Q values, right? ARIMA, if I consider 0 comma 1 comma 0 with double quote, is known as random walk model. Why it is random? I have added only one difference is there, right? Only in second place I have added 1. So in ARIMA only one difference used and make series stationary. No need autocorrelation and moving average called random walk model. So this random walk model we do not have to place for P values and Q values. We let it as a 0 0 and we only put difference value is 1. So we can fit and forecast ARIMA model in R using in R. If we talk about R, right, we have to install forecast model. Thank you so much for this.